completely new area of material science has emerged. A brand new lever we've never had access to before. Imagine a material lighter than foam but stronger than steel. A substance so tough it could replace titanium in airplanes, reinforce space shuttles, and redefine automotive safety. Well, it's no longer a fantasy. Scientists have just used AI to design a new nanomaterial that shatters the limits of what's possible. The craziest part, it was created using machine learning and a 3D printer. We're talking about a material that's 5 times stronger than titanium while being incredibly lightweight. That means lighter, stronger aircraft, fuel-efficient cars, and even more durable technology. But how exactly did I design this super material? And what makes it so different from anything humans have created before? That's where things get fascinating. I just solved one of science's biggest challenges. From the size of our airplanes to the height of our skyscrapers, feats of engineering just keep getting bigger and bolder. But bigger isn't always better. Sometimes, smaller is smarter. The biggest challenge in material science has always been the trade-off between strength and weight. Strong materials like steel and titanium can handle extreme forces, but are heavy. On the other hand, lightweight materials like carbon fiber and styrofoam are too fragile for heavy-duty applications. Scientists have been experimenting with nano-architected materials, materials engineered at the microscopic level with precise, repeating structures. This technique helps create materials that are both strong and lightweight. But there's a problem. Many of these materials are brittle. They can withstand force but tend to shatter suddenly when they fail. That's where AI comes in. Researchers at Caltech and the University of Toronto realized traditional design methods weren't enough. So instead of relying on human intuition, they turned to machine learning to explore entirely new material structures. The AI was trained on thousands of different nanolattice designs, analyzing which shapes distributed stress the best while remaining incredibly strong. It didn't just replicate existing models, it predicted brand new geometries that had never been considered before. The result? A nanolattice material 5 times stronger than titanium and significantly lighter. So how does it work? The science behind this breakthrough starts with nanomaterials, extremely small substances used everywhere from healthcare to electronics. Though small, they deliver powerful performance. This new material is based on a structure called a nanolattice, a microscopic network of interconnected struts and nodes that evenly distribute stress. This prevents weak points from forming, a common cause of structural failure. Researchers used ultra-precise 3D printing techniques to create these nanolattices at the microscopic scale. The final product has a stress tolerance of 3 megapascals per cubic meter per kilogram. 5 times stronger than titanium and much lighter. To put it into perspective, replacing titanium components in airplanes with this material could reduce fuel consumption by roughly 80 liters per kilogram replaced per year. That's not a small upgrade. That's an industry-changing breakthrough. What's more, this material isn't just strong, it's also incredibly resilient. Unlike traditional nano-architected materials, which tend to be brittle, this AI-designed structure can withstand extreme stress without catastrophic failure. This opens doors for everything from next-gen spacecraft to bulletproof armor. And we're just scratching the surface. This isn't a lab curiosity. It has the potential to transform multiple industries. A material lighter than foam yet stronger than steel could revolutionize aerospace, automotive, military defense, and consumer electronics. So how exactly could this AI-designed nanomaterial change the world? Let's break it down. Aerospace and space exploration aircraft and spacecraft are limited by weight. Every extra kilogram adds fuel costs and reduces efficiency. If successfully scaled, this material could replace titanium and aluminum in airplanes, making them lighter and more fuel efficient. NASA and SpaceX could benefit from stronger, lighter spacecraft, reducing launch costs. Helicopters and drones would be more agile and fuel efficient, with longer flight times and greater payloads. Even satellites could last longer with enhanced durability and lower launch weights. Automotive industry in cars, reducing weight boosts fuel efficiency. Integrating this material into vehicle structures could lead to lighter, stronger electric vehicles, ADAS, that travel farther on a single charge. It could also improve crash resistance without adding weight. Over time, 3D printing could reduce production costs and bring these benefits to mass markets. Military and defense, this material is ideal for body armor and helmets, offering maximum protection with minimal weight. It could also be used in lighter armored vehicles, improving speed and durability. Drones made with this material would be more resilient, with longer ranges for tactical missions. Consumer electronics, this material could make smartphones and laptops lighter and tougher, with less risk of shattered screens. It could enable wearables like smartwatches and our devices that are virtually indestructible. Even stronger, lighter batteries could enhance both gadgets and EVs. And this is just the beginning. Scientists are already working to scale production and apply this AI-driven design method across more fields. But there are still major challenges ahead: scaling, cost, and regulatory approval.